Okay, welcome to this another tutorial, and today I'm going to discuss the implementation of a Turing machine, how to determine 2's complement. Like we have previously seen how Turing machine is used to get 1's complement by using the principle of a transducer. So today we are going to use the same principle of a transducer, and today we are going to get the 2's complement method. Now 2's complement is, we all know that by simply changing the bits to zeros, changing the bits of respective zeros and ones, and then adding a 1 to the units, the rightmost position, which is pretty easy. We have all seen the methods in digital electronics. So how a Turing machine does is a bit differently. I mean, the logic behind this is we are going to see right now. So here it is. Turing machine as we are going to see Turing machine as a transducer, and we are going to implement 2's complement. Now 2's complement, what is 2's complement is, suppose the number given is 0, 0, 1, 1, 0, 0. Now how to determine 2's complement of this number? We just take this number and we do the 1's complement, like 1, 1, 0, 0, 1, 1, which is the 1's complement, and then we add 1 here, like which would give me the result as 0, again 0, then 1, 0, 1, 1, right? That's the 2's complement. Now here is a interesting pattern. I hope most of you guys have have idea of this, but still, for those who don't have the idea, I'm going to point this out. Like, this is my main number, the input, and this is the output. This is my output. Now, as you can see that these zeros and these zeros up to this 1, they are all matching. So we are going to use this technique while complementing the given input to 2's complement. Transforming the 2's complement is that from the rightmost side, the rightmost bit, we are encountering any number of zeros. Any number of zeros are being encountered, and we are going to leave them as it is. And as soon as the first one, which is here in this position, is encountered, we are going to leave that one as it is, and from then we are going to complement every bit to its 1's complement rule. Like zeros are converted to ones and ones are converted to zeros. So this technique is going to be helpful in case of designing the Turing machine, because we know that Turing machine can move right and left. So we are going to implement this method to determine 2's complement, and we are going to see how a Turing machine does that. So I'm going to erase this thing because we have seen this. Now the most important part is in the start state, which is QS. Now my intention is to go to the rightmost bit. Now for example, let's take the input here. Input is 0, 0, 1, 1 and 0, 0. So this is my input, and at this side is blank and this side is blank. This is my input. So since this is my input, now what we are going to do is we are going to move to this point. This is my pointer here at the beginning. So we're going to move this pointer up to this last bit, that is 0, and then we're going to move back from here again. But keeping in mind that we're going to leave all the zeros as it is, and as soon as the first one from the right is encountered while moving left, we are going to keep that one as it is, like the 1 is going to be kept as 1, and from then we move left while complementing the each 1's and 0's like we do in 1's complement. So that's the principle we're going to follow. So in the start state QS, if we are going to encounter any number of zeros and any number of ones while moving right. So any number of zeros, keeping it as zeros and moving it right, and while one, keeping it as one and moving right. So I'm moving right, and till how long I'm going to move right? Since the blank is encountered, so the blank, I encounter a blank, keeping it as blank. Then again, now since I have encountered the blank, my job is to move left. So if moving left, right? Now, then again Q1. Here, encountering the zeros, 0 as 0, move left. Ones, not here. I'm keeping all the zeros as it is. Now, as soon as my first one is encountered, I'm keeping it as 1 and moving left to Q2, because I have to remember this step, because the first one I see, I know that I have seen a 1 and I'm going to the next state. So keeping it as going to a new state Q2, and now what happens is we are going to change every zeros to its 1, move left, every ones to the zeros and move left, because now we are just going backwards, right? So we are done with this. Now we are going to move left, right? So now till we are going to encounter this blank, we are going to move left. So cute. Now here the transition would be. Now as we have seen the blank, this one, because we are moving left, now we have encountered this blank, we are going keeping this blank, now we are just moving right, we are moving simply right, because this is important, because to keep the pointer from blank to this leftmost bit, because we are going to read from the leftmost bit, right? So this is the QF, and that's the halting state, because I'm not doing any kind of operations here. I haven't described any kind of transition function over here. So the Turing machine is going to halt at this state. This is acting as my final state, but still I won't call it as a final state. Rather, I would say it's the halting state. And one thing keeping in mind, that I have assumed that this 2's complement won't generate any kind of overflow. Like how many the number of bits given in the input is equal to the number of bits in the output. There shouldn't be any overflow. Then this Turing machine is going to work. Now, if you think that this Turing machine is not working or kind of thing, but then you can take more examples, like any other examples, and then you can trace this out. And while tracing it out, you can check all the configuration, all the moves, all the transitions, and where the dead configuration occurs and where the Turing machine would halt. So yeah, this is my explanation of Turing machine as a transducer for 2's complement, and hope it is clear. And next we will discuss about Turing machine as a adder. So guys, thank you very much, and please subscribe to my channel and share it with your friends and those who want to learn in a simple way. I'm doing this as a very new YouTuber, so your support would be phenomenal. Thank you.